Raw data just means that you've got the actual numbers in a list. And I'm going to run over how to do the mean and variance and show you the correct notation to use. So when we calculate the mean, we start by adding up all the data, and we write that mathematically like this. That means the sum of x, all the x's, all the bits of data added up. In this case, 6 add 7 add 8 add 10 add 12 add 13 add 14 add 17 add 17 add 17 blah 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 blah, which comes to 833. Unless I've gone wrong, which is always a possibility. Okay, so then the mean, we're going to do the, and the mean is, we use this notation, x bar. The mean x bar is all of the x's added up, divided by the total amount of data. In this case, 833 divided by 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 30, 31. 833 divided by 31, which is, now, I've used my formula, I've used clear substitution into the formula. I'm now going to write down my full calculated display and then reduce it to 3 significant figures. So, x bar equals 26.87096774, and then I'm going to say what that is to 3 significant figures. 26.9. 3 significant figures. Now on to the standard deviation, which is the square root of variance. So standard deviation is the square root of variance, and the variance we're going to find first, and then if we need the standard deviation we can square root it. So to get the variance, we take all of the x's and we square them. So that'd be 6 squared, 7 squared, 8 squared, 10 squared, 12 squared, 13 squared, 14 squared, like that, all individually squared. Then we add them all up, and then we find the average of them, basically the average of the squares. So we divide that by n. And then we remember to take away, this is variance, we remember to take away the mean squared. The mean squared. But use the exact mean, please, not 2 decimal places, the exact mean. Okay, I've added all of these up, and it comes, well, all the squares, so all those squares add up to 28093. And that's 50 squared, add 50 squared, add 49 squared, add 46 squared, add 45 squared, add 45 squared, add 41 squared, etc, etc, etc. Dividing that by 31, which is the amount of data, and then taking away the exact mean, which is 833 over 31 squared. Okay, sticking all that in the calculator, we get 884.1768991. So the variance is that, and then the standard deviation is the square root of that, which is 13.57117899. That's my full calculator display, and so that's 13.6 to 3 significant figures. So that means on average, the data deviates, moves away from the mean by an average of 13.6. That's the average deviation, the standard deviation from the mean. The average difference between a randomly chosen piece of data and the mean is 13.6. Okay, have a go at working out the mean. That's x bar, sum x over n. And the variance, we're not going to square root it this time, we're just going to do variance. And the variance, which is all of the x's squared, then added up, divided by n, minus the exact mean squared. Pause video, have a go, then unpause when you're ready to check your answers. So here's the answers. I added them all up to be 2040 and 33 bits of data, so 2040 divided by 33 gives full calculated display of that, and then 3 significant figures, 20.6. For the variance, I added up all of those numbers squared to be 135862. Divide that by 33 and take away the exact mean. I know I'm going on about this, but loads of students don't do exact. The exact mean squared, full calculated display, 3 significant figures, 296. If you did want the standard deviation, it would be the square root of this number, not the reduced number. So you would go back to your full version and do the square root of that, and then you would do all the calculated display, and then 3 significant figures would be 17.2. That's if you did want standard deviation for square root of variance.